You're likely familiar with Schrodinger's cat. You put it in a box with radioactive material and you don't know whether it lives or dies until you open the box due to the principle of quantum superposition where it can exist in both states. But what if I told you there was a far more interesting quantum principle? Instead, what if we didn't know whether the cat was inside or outside the box at any given time? This is quantum tunneling. In classical mechanics, when a particle reaches an energy barrier that it has more energy than the particle itself, the particle won't be able to make it through. However, in quantum mechanics, almost all particles can be represented by a wave function that holds all information about their states.
Possibility that as a wave, it can not only make it around, but straight through the barrier while losing a little bit of its energy or amplitude. But how does that relate to Herbert? Let's get started by taking a look inside Herbert's cells. As with any living being, he has DNA, which has AT and GC base pairs. These base pairs hold the genetic information that make Herbert, Herbert. These bases are held together by hydrogen bonds, very strong intermolecular attractions. But what if one of the protons, another subatomic particle, in these hydrogen bonds tunnels? Well, you get the tautomeric form of this DNA, which causes a mutation if it happens during cell replication. Wait, I still don't get it. Why is my cat related to a solar cell? Could he grow two heads if its DNA mutates? Well, cat-loving me, a similar mechanism happens in solar cells, except not with protons, with electrons. Now, there's a certain type of solar cell called a tandem solar cell that has two types of semiconductors, P and N. P has more holes, or places where electrons can be accepted, and N has more electrons to give, meaning both of these are charge carriers. Now, in semiconductors, there's something called doping, which is when you take the material that the majority of the semiconductor is made out of, for instance silicon, and you add in some doped elements like phosphorus, which has an extra electron. Here comes the fun part. When semiconductors are doped, their conductivity increases, and at junctions where P and N semiconductors meet, if the doping gets high enough, electrons can jump straight from the P to the N because the barrier becomes just thin enough, around 5 nanometers, that they can pass through. Hence quantum. Oh, pretty cool. Though I think I like the cat DNA part better. Herbert's pretty awesome.
Now, even though all of this seems really cool and almost like magic, it's not. Here are the sources that explain exactly how these processes work. Thank you!